Hello friends, welcome back to my channel. Now, in previous lecture we have already learned some concepts regarding operations on real number. Then we have remind some identities. Right now, in this lecture, we will complete exercise number 1.4, and here is our first question. We have to identify whether these numbers or these expressions are irrational or not. Now, first one is 2 minus root 5. Here 2 is rational and root 5 is irrational. So obviously here we have one rational and one irrational. So subtraction between one rational and one irrational will be always irrational. So this is irrational. Now second one is 3 plus square root of 23. This is in the bracket. Now there is a sign of subtraction, and again we have square root of 23. So first we will simplify this, right? We cannot directly say whether this is rational or irrational. So we will do simplification. Now this is just a case of addition and subtraction. So I can write it here as 3 plus square root of 23 minus square root of 23. Now I can cancel it because here we have plus sign and here we have minus sign, and both the numbers are same. So I can cancel it. So my answer will be 3. Now we all know that 3 is rational. So my final answer will become rational number. Now here we have 2 square root of 7 divided by 7 square root of 7. Now I can simply cut out this. So after cutting, I got 2 divided by 7. Now we all know that it is in the form of p by q, where p and q are integers and q does not equal to 0, right? So it is obviously rational number. Now here I have 1 upon root 2, right? 1 upon square root of 2. Now division between one rational and one irrational is always become irrational. So it's just simple, I can write it is as rational. Now here I have 2 pi. We all know that pi is irrational. So 2 is rational. Rational multiply irrational, answer will be irrational. So we can just say, if we know these two, right? Addition between one rational, addition or subtraction between one rational and one irrational always become irrational. Multiplication or division between one non-zero rational and one irrational always become irrational. Now here is our second question of exercise number 1.4. I have to simplify all this, right? Let us do a first question here. Here I have 3 plus root 3 multiply 2 plus root 2, right? So let me write all the things that we have learned in previous lecture that can be used in here. If I want to multiply root a with root b, I can simply write is at square root of a multiply b. For all the identities like a minus b multiply a plus b will become a square minus b square. A plus b whole square will become a square plus 2ab plus b square. Now a plus b multiply c plus d can be written as, I have to multiply a with these two, then b with these two, so ac plus ad plus bc plus bd, right? This is simple answers, and we all know this, right? These three we have already learned in standard 8, and we all know that square root of a multiply square root of b is equal to square root of a multiply b. Now here we have first question, that is 3 plus square root of 3 multiply 2 plus square root of 2. This is the case of a plus b multiply c plus d, right? You just have to identify what type of question is this, and you will get answer easily, right? So it is 3 plus square root of 3 multiply 2 plus square root of 2, simply as a plus b multiply c plus d, right? So I have to multiply 3 with this bracket, then I have to multiply plus root 3 with this bracket. So multiplying 3 with this is 3 to the 6 plus 3 multiplied root 2 is 3 root 2 simply. Now root 3 multiplied 2 is 2 root 3, and root 3 multiply root 2 is, let me write it here. So it is 6 plus 3 root 2 plus 2 root 3 plus I can write it as root 6, right? So it is our answer. Now we will move on to the second question. Here I have 3 plus root 3 multiply 3 minus root 3. Just see the question and find what type of question is this. It is simply as a plus b multiply a minus b, right? So our answer will be easily a square minus b square. Here, here 3 is a and root 3 is as b. So I can write it as 3 square minus b square, that is root 3 square. So 3 square equal to 9. Now root 3 square is, we all know that square root of a will become a, or square root of a multiply square root of a, right? So root 3 square will become 3. Simply square and square root both will be cut, right? So 9 minus 3, that is 6. So 6 is our answer for question number 2. Now for the third question is root 5 plus root 2 square. Now it is in the form of square of a plus b, right? So answer will be a square plus 2ab plus b square. Now here we have root 5 in the form of a and root 2 in the form of b. So I can simply write it as root 5 square plus 2 multiply root 5 multiply root 2 plus root 2 square. Simple. Now what is square of root 5? I can simply write it as 5. Now plus 2. What is multiplication of this both? Root 5 multiply root 2. I can simply write it as square root of 10, right? Now what is square of root 2? Simply we can write it as 2. Now I can add 5 plus 2, that is 7 plus 2 square root of 10. Easy. Now we will move on to the fourth question. Let me do it here. Fourth question is root 5 minus root 2, root 5 plus root 2. Now identify the type of question. It is simply as a minus b and a plus b. Our answer will be a square minus b square. So in the form of a, I have root 5. So I can write it as root 5 square minus root 2 square. Very simple, right? So root 5 square is 5 and root 2 square is 2. 5 minus 2, our answer will be 3, right? So to simplify this type of question, you just have to remember the identities and you just have to identify which type of identity can be applied on this type of question, right? It is very simple. You don't have to panic. In standard 8, you have already done this type of questions. Here we have just one thing that is added is number with square roots, right? Now we will move on to the third question. Now this is third question. This question is very interesting. What is said here is pi is defined as ratio of circumference c of the circle to the diameter d, right? Now that is pi equal to ratio of c by d, right? Now this seems contradict the fact that pi is irrational. It is in the form of pi equal to p by q, and any number in the form of p by q is rational, and we have earlier said that pi is irrational. So they said this is contradiction of pi is irrational. How will you resolve this contradiction? So first of all, we will see what this question is trying to say. We all know that for this is not a circle. For any circle we have radius r and circumference c and a diameter d, right? Now circumference c equal to 2 pi r for any circle and 2r equal to d. So circumference c will become pi d, and pi equal to c by d. I just put d onto the other side of equal to sign. Here it is in multiplication, so I get it is in division. So pi equal to c by d. Now doesn't it look like in the form of p by q, and any number in the form of p by q is rational number, so pi will become rational number, but we all know that pi is irrational number. So what is the reason behind this? Now here c and d is length of a diameter and a circumference. What I am saying is c and d is a length of diameter of a circumference. Now if I take a p by q form, we all know that P and Q should be any integers, right? And Q does not equal to 0. P and Q should be any integers. So I have to take an exact value here in the form of P and in the form of Q. Now, what if value of C and D will be like infinite digits after decimal point? What I am saying is, in the real world, if I measure the length of anything, let's say I want to measure length of this line segment, it depends on the device that you will use. If I measure length of this with scale, let's say length will be 10.3 centimeter. Now if I measure length with some more precise device, like I will measure the length with some big vernier calipers or anything, my length will come, or this length can come 10.356. Now if I use more precise device or any more digital device, length can be 10.3567889, right? So in real life we cannot measure value of exact length, we only take a approximate value, right? So if I measure the length of this line segment, I can take approximate value as 10.3. Let me give you an example. In a race, if one person cross the line or a finish line at some point, now there is a referee who is measuring the time of crossing the line. Now if he has a clause that measures a value in minutes and seconds, that is like it crosses the finish line in 10 minutes and 36 seconds, right? Now if he has a more precise clock, value can become is 10 minute 36 65 36 seconds and 35 milliseconds. Now if we will use more precise clock, value can be more precise clock value can be more specific, right? So I am saying is, in real world we can not measure exact value because it depends on the device of the measurement. So we only take a approximate value for calculations. So here in any question you take a C and D, you only take an approximate value. If I measure a real value of diameter D or circumference C, let's say this is a diameter D, if I am starting using more and more and more precise device, my value of D will be like non-terminating non-terminating decimal expansions, right? That we have studied earlier. So it can be, so if I want to write a P by Q form that is rational, I have to use a P and Q as integers, and here C and D are not integers, right? So the value of pi is always irrational. In this case, C and D, we take approximate value of C and D. So it will get, in some question we will use 22 by 7, or in some question we will use 3.14. That is approximate value of pi, right? This is a cousins of pi, but only king is pi, that is irrational. And we are succeed to get 1.26 trillion digits after a decimal place for the pi. So in real world we only can measure a approximate value of any length. C and D are measurement of length. So value of pi is not in the form of P by Q, where P and Q are integers. So value of pi is always irrational, right? And there is one more concept that you should learn, and that is, if I cut down this circle from here, let me say a point here is A and point here is B. If I put a string that I have cut down a circle, I have put a string here from point A to point B. Now I can cut the circle in exactly 3 parts, such as the value of this part will be D, D and D. Now we have this part remaining. Right? What I'm saying is, I have cut down a circumference. Circumference is the outer boundary of circle, right? I have cut down a circle and put a string here, that is exact circumference. Now I can cut it, or I I will start put a length of diameter on the circle. I will get exactly these three part value of d, right? Now this part is remaining. This part is exactly 1.1415 multiplied by d. So if I put all this value together, d plus d plus d plus 0.1415, and it will go on up to d, multiply d, right? So if I add this 3, this is 1, 2, 3 times, and if I add this will become 3.1415, and it will goes up to n multiplied by d. So value of this is value of pi multiplied by d. So you can try to measure a length of any particular circle. If you measure this length, this is exact value of decimal points that are after 3 in value of pi, right? So what I am saying is, if you take a ideal circle, if you take a ideal circle where the lengths are exactly in a form of integers, then you get a value of pi as 22 by 7 or 3.14. If you take an ideal circle where lengths are in form of integers, but there is no ideal circle for which length are is in exactly form of integers, because you start using more precise device, you will get more digits after decimal points. If you again use even more precise device, you will get again more decimal points after, decimal digits after decimal point, right? So here is the concept that there is no contradiction that pi is irrational number. Value of c and d is a measurement of length, and measurement of length can be not precise. We only take an approximate value of measurement of c and d. So I can write that there is no contradiction because C and D are lengths, and we can only get approximate values of measurement of length. And for rational number, P by Q, P and Q both should be integers. Q does not equal to 0. And in case of length, we cannot say lengths are always in form of integers. So this is the reason you can give. You can give a reason in any your language. The main concept is C and D are values of measurement of length, and it cannot be precise. We only take an approximate value, so we cannot say that pi is in the form of P by Q, where P and Q are integers. Now here we have our fourth question, that is we have to represent square root of 9.3 on the number line. We have already learned a method in previous class. So what will we do is, we draw a line segment of length 9.3 with a scale. Now we will extend it to exactly 1 unit from this, right? Let me name it A. Here I can name it B, C, right? So first I have drawn a line segment of unit 9.3, that is AB, and I have extended for one unit. You can just do a simply 9.3 centimeter and 1 centimeter. Now what I will do is I will find a middle point of A and C. Let me name it as O. This is the middle point of A and C. Now I will draw a semicircle. So here a semicircle is drawn out of C. So here is a semicircle with radius O. So first step is draw AB equal to 9.3 centimeter per unit. Then draw BC equal to 1 centimeter line AB, right? Or I can say extend it is. Now find a O such that AO equal to OC, right? AO equal to OC. Length of O, I don't have to write length of O. Right? Now AO equal to OC. O is a middle point of A and C on line AC. Right? Now fourth step is I have to draw a semicircle. Draw a semicircle with radius AO and center O, right? I have drawn a semicircle with center O and radius AO. Now in the fifth step I have to draw a perpendicular on line AC. Perpendicular on line AC. It will be touch a semicircle. Let me draw it. A perpendicular on line AC. Oh, sorry, it does not look like a perpendicular. I have to draw perpendicular on line AC that passes through point B. So this is perpendicular on line AC that passes through point B. It touches the semicircle at point D. So let me mention it. Now draw a perpendicular on line AC that passes through point B, right? That passes through point B. It will touch the semicircle at point D, right? Now value of BD is a value that asked in question. So measure the length of BD, that is exactly like square root of 9.3, right? We don't have to mention the concept behind it. We all know that here we have drawn we have used a Pythagoras theorem to find this value, right? Now draw a number line in which draw a point 0. Here we have 1, here we have 2, here we have -1, -2. Now we have already find the measurement of length BD. Just put 1.4 of your scale in another point where length of BD stops. It will come as something like here, it is our square root of 9.3. This is the length of BD, right? So it is very simple. Now we will move on to the question number 5, and that is we have to rationalize the denominators. Now for question number 5, rationalizing the denominator, first is 1 upon square root of 7. Remember what we have done to rationalize the denominators. If the denominator is monomial, we will simply multiply and divide the same number. So let me multiply and divide with square root of 7. Now 1 multiplied square root of 7 will become square root of 7. Square root of 7 multiplied square root of 7 will become easily 7, because I can write as square root of a multiplied square root of a equal to a, right? Oh, I have already written here square root of a multiply a is equal to a. So square root of 7 multiply 7, square root of 7 will become 7. Now now this is our answer, right? Here we got a rational number in the denominator. Now for second, we have 1 upon square root of 7 minus square root of 6. When we got a denominator as binomial and we want to rationalize it, what we have done is we will multiply and divide it with a conjugate of that number. And what is conjugate? Just simply change the sign between these two numbers. So I will multiply and divide with conjugate of that number, and that is I will just put a, here I have negative sign, so I have just put a positive sign here. Now in the numerator we have multiply this, so value of numerator will become square root of 7 plus square root of 6. Now in denominator I have the form like a minus b multiply a plus b, right? Here you can see a minus b multiply a plus b. So my answer will be a square minus b square. So I can simply write square root of 7 in place of a square, in place of a, and in place of b I have to write this. So numerator as it is, in denominator square of square root of 7 will become 7. This both will cut, this both will also cut. So 7 minus 6, my answer will be square root of 7 plus square root of 6. Very easy, right? Because in denominator I have 1. You can write it or you can ignore it if you want. Now 1 upon square root of 5 plus square root of 2. Again, very easy question. Here we have binomial, so we will multiply it and divide it by conjugate of that number, and that is square root of 5 minus square root of 2. Just change the sign between them, right? Now in the numerator I have 1 multiply this, so it is root 5 minus root 2. In denominator I have a plus b multiply a minus b. Simply it is a square minus b square, so I can write root 5 square minus root 2 square. Now root 5 minus root 2 divided by root 5 square minus root 2 square, that is 5 minus 2. So root 5 minus root 2 upon 3, right? So this is our answer. Now fourth is 1 upon square root of 7 minus 2. 1 upon square root of 7 minus 2. Now here we have binomial, so what we will do is multiply and divide it with conjugate of that number. So just add a positive sign between them. Now in the numerator there is nothing to change, so square root of 7 plus 2. In denominator I have a minus b multiply a plus b, that is a square minus b square. Just simply write it as root 7 in place of a, that is root 7 square minus b square. We have b in place of b square, so it is 2 square. So root 7 plus 2, that will come same as it is. Now in the denominator we have 7 here. Now 2 square equal to 4. So root 7 plus 2 divided by 7 minus 4, that is 3. So it is our answer. So in the exercise number 1.4, we have identified whether the addition or multiplication of two numbers is rational or irrational. That was our first question. We can find it with these two. Now then we find how to simplify, or sorry, we have done a simplification of numbers, right? We have used some identities like these three, and there is a most important identity, that is a minus b multiply a plus b, that is a square plus b square. This identity is used on in those questions. Then we have learned how to represent number like square root of 9.3 on number line. The process is very easy for this. Now a rationalization of denominator, right? So these four things you have to learn in exercise number 1.4. Now we will learn some concepts and then we will do exercise number 1.5. Now before going to the exercise number 1.5, let us recall laws of exponents. You already have learned it. What I am saying is, if you have 2 power 3 multiply 2 power 4, what is answer of it? You can simply write is as, here we have same base, so and there is a sign of multiplication between them, so we can just simply add powers. So I can write it as 2 power 3 plus 4, that is 2 power 7. You all know this, right? In second case, if there is a division, what will you do? Here we have same base, so you just simply do a subtraction of power. So our answer will be 2 power 1. You all know that. Now what if we have 2 power 3 multiply 3 power 3? Here we do not have same base, but we have same powers. So what we will do is, we will put power as the same, but just multiply the base, that is 3 to the 6 power 3. What if I have division of numbers with the same power, not same base? Just put a power and divide the number, right? We all know this. 6 to the 6 divided by 2, that is 3, so it will be 3 power 3. Now for the fifth one, what if 2 power 3 power 4? We all know that we just simply multiply the powers, that is 2 power 3 multiply 4, that is 2 power 12, right? Now we all know this for natural numbers only, right? But it can continue on rational numbers and real numbers too, right? So we will do examples with real numbers for the same kind. Let me write it here for you, that this is same as a power m multiply a power n equal to a power m plus n. Second one is a power m divided by a power n, that is a power m minus n. Right? We have done same the process that I am writing here is. Third one, a power m multiply b power m, that is a multiply b power m. For the divide, we will do the same. A power m divided by b power m. Here power is same, right? So a by b power m. A power m power n equal to a power m multiply n. Right? So these all the things that we have already know in our run in standard 8. Now what I am saying is, here a, b, m, n, all the things are in positive, right? All the numbers are positive, or we can say all the numbers are whole numbers. But we can continue it in integers or a rational number or a real number also, right? If a and b is a positive real number, that is greater than equal to 0, greater than 0. If a and b is positive real number, I can write a power m equal to b, then a equal to mth root of b. I told you in the previous lecture, if you remember that 2 power 3 equal to 8, then I can write 2 as cube root of 8, right? 2, 3 power 2 equal to 9, then 3 equal to square root of 9. It is very easy, right? So now if I want to represent this type of numbers, or let's say I want to represent square root of 2 or square root of 9 as a form of exponent, I can write it as 2 power 1 by 2. Here I can write it as 2 power 9 by 2, 9 power 1 by 2. Here b power 1 by 2. What I am saying is, to represent mth root, I can use a sign b power 1 by m, right? You don't have to operate by watching this type of power. These rules will apply on any type of power, right? We will use the same rules that we are using in standard 8. Now let me write let's say I have to write 7 square root of 10. I can write it as 10 power 1 by 7. So this is the another thing that you have to learn, that a power m equal to b. Then I can write it as a equal to b power 1 by m. If I remove power from one side of equation and move it to the other side of equation, I have to write as a division, right? 1 upon m. So this is another thing that you have to learn. Now we will do some examples. Let's say I have to do 3 power 2 multiply 3 power 3 divided by 3 power 7. What will be the answer? So what I will do is 3 power 2 multiply 3 power 2, that is 3 power 3 to the 3 plus 2, that is 5, divided by 3 power 7. So here I have same base and different powers, so I have to divide the powers, that is 3 power 5 minus 7, that is 3 power minus 2. Now 3 power minus 2 I can write it as 3 power 1 by 3 by 2, right? So again we get another value. If I have a power m, I can write it as 1 upon a power minus m, or if I have a power minus m, I can write it as 1 upon a power m. If I have a negative power and I want to make it positive, I just have to put this number in denominator, right? So it will be our answer. Now what if I have 3 power 12 multiply 3 power 1 by 2? Process will be same, rules will be same. Here I have multiplication, same base, I just have to add the powers. So 3 power 12 plus 1 by 2. Now simply add 12 plus 1 by 2, answer will be 3 power, I have to take LCM, so it is 25 by 2. This is our answer, right? Now again, if you want to simplify this, what I am saying is, if you want to simplify the question like 2 power 2 by 5, oh sorry, let me say 32 power 2 by 5, I want to find the value of this. So what I will do is, if I expand it, I can write it as 32 power 2 again power 1 by 5. What I have written is, if any question is in this form like a power m in bracket and then power n, I just do a multiplication of powers. Here I have 32 power 2 and after bracket I have power 1 by 5, so I just do a multiplication of these two powers, that is 32 power 2 multiply 1 by 5, that is 32 power 2 by 5, right? So I will use this form to find the answer, right? So let me write it as 32 power 1 by 5 and then we have power 2, right? I can write any type in this type of question in this form. Now 32 power 1 by 5, that means fifth root of 32, right? Fifth root of 32 power 2. Now you have to find a number that such that if you multiply that number 5 times, you will get answer as 32. We all know that 2 power 5 equal to 32, so 2 equal to 32, fifth root of 32, so I can write 2 instead of this, so 2 power 2, that is 4, right? You will get it easily once you do 2-3 examples of same kind. So the main thing is, we will use the same methods that we are using for the exponent and powers for real number also, right? Just we have this new thing to remember, right? If I remove power from one side of equation and want to put a power on another side of equation, I will do it is a 1 by m, right? Now here is our 20th and last example for this chapter. We have to find the value of this, or we have to just simplify this, right? Now our first question is 2 power 2 by 3 multiply 2 power 1 by 3. Remember, this is all the question of exponent and power simply that you have already done in standard 8, right? And you just have to apply these rules that you have already known. So our first question is 2 power 2 by 3 multiply 2 power 1 by 3. Here we have same base and multiplication of it. So we'll just add the powers. So let me put a base is 2. Now just add the power, that is 2 by 3 plus 1 by 3. So after adding it, we'll got that 2 power 3 by 3, that is 2 power 1, because addition of this will be 3 by 3, and 2 power 1, that is 2, right? So very easy. Now second question, we have 3 power 1 by 5 in the bracket and then power 4. It is exactly the same as a power m power n, right? So we will just multiply the powers. So let me write it as 3 power 1 by 5 multiply 4, right? So it will be 3 power 4 divided by 5. So this is the answer. Very easy, right? Just you have to apply rule. Now here we have 7 power 1 by 5 divided by 7 power 1 by 3. Here I have a same base and division of these two numbers. So I will subtract the powers. 7 power 1 by 5 minus 1 by 3. Very easy, right? Now after subtracting it, I have to take LCM for this. So my answer will be like, my LCM will be 15, right? So here I have to put 3 minus 5 divided by 15. So my answer will be 7 power minus 2 divided by 15. Now if you want to convert this power in positive, what will you do is, you can put this number in the denominator and the power will be automatically converted into a positive, right? So I can simply write it as 1 upon 7 power 2 by 15. Very easy, right? Now here we have fifth question, that is 13 power 1 by 5 multiply 17 power 1 by 5. Now here we have different bases but same power. It is this type of like a power m multiply b power n. So we will just multiply the powers, that is 13 multiply 17 and keep the power same. 13 multiply 17, what will be the answer? 7 3 are 1, power 2, so again 2, again 2, so 221 power 1 by 5. So it will be your answer, right? So these are the simple rules that if you remember this rule, you can answer this type of question. Now we'll move on to the exercise number 1.5, the last exercise of this chapter. Now here is our exercise number 1.5, the last exercise for this chapter. So we have to find the value of these. We have three questions here. In first one, I have to find value of 64 power 1 by 2, 32 power 1 by 5, 125 power 1 by 3, right? We will apply the same rule that we have learned just before these rules for power and exponents, right? So answer for our first question is 64 power 1 by 2. I have to find a square root of 64, and we all know that square root of 64 is 8, because 8 multiply 8, that is 64. So it is the first question. Now for second, 32 power 1 by 5, 32 power 1 by 5. What will be the answer of 32 power 1 by 5? It is simply a fifth root of 32, and that is, what is the number that we, if we multiply this number 5 times, my answer will be 32, and the number is 2. We all know that 2 power 2 equal to 4, 2 power 3 equal to 8, 2 power 4 2 power 4 equal to 16, 2 power 5 equal to 32, right? And for this, we all know that 7 square equal to 49, 8 square equal to 64, right? So I can write 8 as square root of 64. This is as simple as that. I can write this is in the form of square root of fifth root of 32 as 2, right? So it is our second answer. Now for third, 125 power minus 1 by 3. 125 power minus 1 by 3. When the power is in the negative form, to convert it in positive, what we will do is just write it in a denominator, right? So 1 upon 125 power 1 by 3. If I want to remove the negative sign, I have to write it in the denominator, right? So now 1 upon 125 power 1 by 3, that is 1 upon cube root of 125. We all know that square root of 5 is 25. Now cube root of 5 is 125. So I can write cube root, let me write it here. Cube root of 125 is 1 by 5. So this is my answer, right? If you know the square roots and cube roots or squares or cubes or of numbers from 1 to 20, you can get easily these answers, right? Now we will move on to the second question. Find the value of 9 power 3 by 2. These are very easy questions. If you know the rules for exponents and powers, you can simply find the answers. Now for second one, 9 power 3 by 2. What we will do is 9 power 1 by 2 power 3. Does it? You can see it is in the form of 9 power m power n, right? I can write 3 by 2 such as 1 by 2 multiply 3. Now it will be easy for us to solve because 9 power 1 by 2, that is square root of 9, and we have power 3. Now square root of 9 is 3. So 3 power 3, that is 27, right? Now 32 power 2 by 5. What we will do is we just separate this such a way we can find easy answer. 32 power 1 by 5 power 2, right? I can write 2 by 5 as a 1 by 5 and power 2, right? So 32 power 1 by 5, that is fifth root of 32, right? And I have power 2. So fifth root of 32 is 2, right? So 2 power 2, that is 4, right? Third question is 16 power 3 by 4. I have to separate it such a way that 16 power 1 by 4 power 3, I can write it as 16 power 1 by 4 power 3. Now 16 power 1 by 4 is fourth root of 16. What is fourth root of 16? I can find it from here. Fourth root of 16 is 2. Let me write it, fourth root of 16 and power 3. So it is 2 power 3. Now we all know that 2 power 3 is 8. So it is our answer. Now here we have, oh sorry, previously I have done 125 power 1 by minus 1 by 3. This is that is answer of this question. Now let me do it. This is very easy. 123 power 1 by 3, that is 5. Simple answer, because 5 power 3 is 125, so 125 power 1 by 3 is 5, right? This is simply a cube root of 125. Now we will move on to the third question. So the rule is, when you find this type of power like 1 by 2, 1 by 3, 1 by 4, 1 by 5, this is simply a 1 by 2, that means square root. 1 by 5 that means fifth root. 1 by 3, that means cube root. So you just have to cube root or square root or fifth root or any number of root that is asked in your question, right? When you got power in the form of p by q, what will you do is you can simply find a nth root. Like I can separate this as a power 1 by 2 and again another power is 3, power 1 by 5 and another power is 2. So I can find a square root of this and then I can do a cube of this. I can find fifth root of this and then I will do square of that answer. I can find fourth root of this and I will do a cube of that, right? So it is very easy for you. When you get negative power, what will you do is you just put a number under the in place of denominator, so the power will be positive. Now for this, here I have a same base. I have to do a addition of power because I have multiplication sign. So 2 power 2 by 3 plus 1 by 5. Now what will be answer of this? 2 power 2 by 3 plus 1 by 5. I have to take a LCM, or LCM will become 15. So my answer will be 2 power 10 plus 3 divided by 15. So it will be 2 power 13 by 15. Now if the power is bigger, you don't have to solve it, right? If power is smaller, you can solve it. Now 2 power 13 answer will be very high, 2 power 15 answer again will be very high. Now here we have second question. 1 upon 3 power 3, and again we have power 7. So I can write it as, if you want to simplify it, you can simply write 3 power minus 3. If I put the denominator in place of numerator, my power will change the sign, right? So here I have power as 3, so I put it as a numerator, I have to change the power, sign of power, right? So 3 power minus 3, again power 7, now it is in the form of a power m power n, so I have to multiply the powers, that is 3 power minus 3 multiply 7. Now minus 3 multiply 7 will be 3 power minus 21. You can simply write this answer, or if you don't want power as negative, you can write it as 1 power 3 by 21, right? If you write it in this form, the negative sign will go. Now for this, here we have same base and here we have division, so I will do a subtraction of power, very easy. 11 power 1 by 2 minus 1 by 4, just do a subtraction of power. Now the answer for this is 11 power, here I have to take LCM and LCM will be 4. So 11 power 2 minus 1 divided by 4, that is 11 power 1 by 4. It is our answer, right? Now I have 7 power 1 by 2 multiply 8 power 1 by 2. For this, here I have different bases but same power, so I have to just multiply the base and keep the power same. So 7 8 are 56 power 1 by 2, I can write it as square root of 56, right? I can write it as fourth root of 11, right? I can write it as 1 upon 21th root of 3. I don't want to write it anything, right? So this is our answer. Now we have completed exercise number 1.5 and we have completed chapter number 1. Watch all the videos for this chapter, do a revision as much as possible, and you will get good marks in your exam, and it will be very helpful in your real life also, right? So thank you for watching this. Now we will go to the second chapter.